when it comes to search information retrieval, how the index that you built is extremely important. And this is really what I view as kind of the powerhouse behind RAG is kind of the index that you have. And ideally, this has proprietary information that when you use it with your AI agent, it allows you to provide value that the AI agent wouldn't otherwise be able to provide because it has access to unique information. So in this world, of super, very intelligent models, we believe that data is still king. At the end of the day, having unique data and then integrating that with your AI agents really is what makes certain AI agents really unique.
Where does the unique data come from?
So this can come from various sources. In general, we think about there being two main sources of data, like public data or two ways of splitting it, public data and private data. So public data is data that's available on the web for public consumption. You'll often see, for example, this is like your Google search index at u.com. We have our own u.com search API, which allows you to kind of access public data. We have a live news endpoint, which allows you to access live news. This is all public data. It's not specific to, it's not private or specific to a particular organization or person. And then there's private data. So private data can come in all shapes and forms, and this is where it gets very, very, different, like kind of, I'll call it miscellaneous. Examples of private data can be, your organization's SharePoint or Notion or Slack. So there's all these different, private sources of information, and often you'll have to build connectors to basically, pipe that data into whatever index if you want to use it in a RAG pipeline. And kind of going back to your initial question of indexing, okay, so there's different types of data sources. There's private data, there's public data. When it comes to indexing, there's often different approaches you can use. So one is what is commonly referred to in the industry as an inverted index. You could think of it as inverted index as being the main way of storing information such that you can get really good keyword matches. So essentially what this does is if you have a query, you can look at the words in the query and see kind of lexical signals from the query and the index to get documents. This has kind of been the standard for decades now. And when you look at, very large indices that often have inverted index as, one of the main pieces behind it. And then the other, piece that has been emerging, with kind of a lot of the advances in natural language processing has been what we call semantic search, or, and what semantic search essentially is you take documents or some information about the documents, you embed them, and then you effectively, you embed your query and you're able to find the nearest set of documents to that query based on the distance between the embeddings of your query and the embeddings of the documents. The advantage of semantic search is that you can, capture similarities between, your document and your query that are not as straightforward as, strict lexical matches. The way I often view it is your inverted index gives you really high precision documents that are really relevant to your query and can often be very useful for, complicated, keywords, et cetera, that, maybe don't have that much, semantic meaning unless you have a very fine-tuned embedding model. And then your semantic search allows you to increase your recall. So with semantic search, you can kind of widen the net a little bit and get documents that you may just be missing if you focus only on lexical signals.